Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Akgec Engineering College, Ghaziabad. I welcome all of you in the lecture series on engineering mechanics. So, I started my lecture series with shear force and bending moment, and in previous 3 live sessions I covered certain things which are necessary, jaruri hai, because if you are not watching these videos, then definitely day by day and slowly we are reaching towards the problem solving. So, before numericals, before problem solving, it is necessary to understand the basic concepts. So, what in previous lectures, so the first 2 lectures I covered about the what basically the beam is, how to find out the support reactions under different loading conditions, certain problems I tried to solve here, so that you will be comfortable in understanding the concept of finding out the support reaction. Okay, so in first 2, in the third one I started my topic with the what? I started my topic with the concept of shear force and bending moment. So, I covered this particular topic on what basically the shear force and bending moment is. So, what basically it is, again in very brief I am telling you what is shear force and bending moment. So, whenever a beam is loaded, it offers the beam material and beam cross section offers certain resistance. So, that internal forces, either the resistive force or the resistive moment by the beam material and cross section, that is what known as shear force and bending moment. I am not going into the much detail why it is known as shear force, why it is known as bending moment, because already covered in my previous lecture. So, please go through that particular lecture. Those who are live, they can write at least Jai Hind, so that I am knowing who all are available. Okay, and wherever you are getting any doubt, please write in chat box, so that in problem solving you are comfortable. Okay. So, shear force and bending moment is clear. Now, how to find out shear force and bending moment? I am not going detail in this, already covered what basically the shear force, because today we are focusing mainly on problem solving. So, shear force at any section Xx is the algebraic sum of all the lateral forces acting either side of the section plane. It means if I am talking about this section plane, तो या तो इसके left side के सारे transverse force और right side के सारे transverse forces. So, it is the algebraic sum of all the forces, algebraic sum of all the lateral forces which are acting on either side of the section plane. Shear force, basically it is a force, so there must be some sign convention. So, sign convention is quite clear. If I am talking about the left side of the section plane and the resultant of all the lateral component is upward, then I will be saying it is a positive. Simultaneously on the right side, if it is a downward resultant, so both will be considered as positive, already covered. Okay, this is the negative one. Similarly for the bending moment, because we don't want ki beam is getting bended through any load, so the beam material must be sufficiently strong to offer certain resistance against the bending. So, that is what known as the bending moment. Okay. And how it will be calculated? How it will be calculated? I am coming to that point. The bending moment M, it is also the algebraic sum of all the moments acting either side of the section plane. Simply I am saying if A is my section plane, so सारे forces जो भी left side में हैं इसके, because of all these forces whatever the resultant moment is on the left side, similarly on the right side. So, this is what known as algebraic sum of all the different moments because of various forces on either side of the section plane is considered as bending moment. इस तरीके से हम उसे calculate करेंगे. Okay, and the sign convention, section plane is shown here. Section plane on the left side, if it is clockwise resultant, on the right side it is anti-clockwise, it is positive, and obviously the opposite of this will be negative. Okay, so this is what known to us. Then we discussed about the relation between shear force and bending moment. Yes, shear force and bending moment, we tried to find out, we established the relation. I am not going into the detail, already discussed. So, if From exam point of view, it can be a question for 2 or 3 marks. So those who are interested in this, they can watch my previous video, lecture number 3. Okay. What relation we established? We established the relation F equal to dm over dx. F is the shear force, m is the bending moment. So we are observing that there is a differential relation between shear force and bending moment. Similarly, load and shear force के बीच में it is equal to W equal to minus dF over dx. But here we are focusing ourselves on the F equal to dm over dx. F equal to dm over dx. So this is the relation between shear force and bending moment. What can we conclude? I am slightly hurried, okay, because all these portions I covered. So that's why I am doing something fast. Conclusion, what we can make from the equation 1? Equation 1 क्या थी? F equal to dm over dx. So shear force diagram का area, the area of shear force diagram between 2 points is equal to the change in bending moment. This is available here. M equal to integration of f dx. Integration of f dx is the area of shear force diagram between 2 points, which will be equal to the change in bending moment between these 2 points discussed. The slope of bending moment diagram is the shear force. Yes, it is well known. F equal to dm over dx. The curve equation is like this. The differential equation is showing this, F equal to dm over dx. Okay. Now I am coming to the point. Differential equation say if f equal to 0, then we can conclude 3 outputs. What? If f equal to 0, shear force is 0, then bending moment can be a constant. Yes, it will be a constant. Okay. And if f is 0, then dm over dx equal to 0, it means this is the condition of maxima or minima. Maxima or minima. So at that particular point where shear force is 0, at that particular point the bending moment will be either maximum or minimum. Already concluded and explained. Okay. So this is what the available here. Okay. Then what is the point of contraflexor? This is also discussed, the point where bending moment changing its nature, bending moment changing its sign, bending moment changing from sagging to hogging. That particular point is known as point of contraflexor or point of inflection. Mathematically, it is the point where the bending moment is 0. Obviously, from positive to negative or negative to positive, if any curve is going, then it must pass through the 0. So the point where the bending moment is 0, that particular point is known as point of contraflexor. Okay. Then shear force and bending moment diagram. It is the loading condition is changing, bending condition is changing. So shear force and bending moment will not remain constant in entire length, in entire span of the beam. तो लेंथ के साथ shear force कैसे vary कर रहा है? It will be shown by shear force diagram SFD. Similarly BMD, लेंथ के साथ bending moment beam में कैसे change कर रहा है? This is what known as bending moment diagram. Okay, this is what done. Okay, now I am coming to the different condition. In different loading condition, what will be the nature, what will be the behavior of the shear force and bending moment, and it is in the table, it is in the form of table. Explain किया हुआ है last lecture में बहुत अच्छे से. आप लोग यदि उसे देखेंगे then definitely you will be able to understand, but summarize I am doing, summary I am presenting here. If the point load is there or no load condition is there, then shear force will be the horizontal line, bending moment diagram will be the inclined line. Okay. If uniformly distributed load UDL is there, then shear force is inclined line. Again, अभी हम फिर से check करेंगे, जब questions करेंगे then it will be more clear. So it is the inclined line and the bending moment will be the parabolic curve. And if it is a UVL, uniformly varying load, then shear force diagram itself will be a 2-degree parabola and the bending moment diagram will be a cubic parabola. So if I am ready with all these details, whatever I discussed in 5 or 10 minutes, okay, then we are ready to solve the problems. So now I am coming to the problem part. So I am starting with a very simple problem, very simple question, and I hope we will be able to understand through this also. So 2 or 3 problems I am trying to take today, and in my next lecture I will be taking 1 or 2 more. Okay, so simply supported beam subjected to a uniformly distributed load. So the question is very clear. So the beam is available, आ गया भाई beam आ गया, how it is, W per unit length, that is what the intensity, L that is the length of the beam. So obviously by the symmetry, अब तो हम इतनी support reaction निकाल लेते हैं कि by the symmetry I can say that WL by 2 and WL by 2 are the support reactions. Okay, so this is. Now for finding out the shear force and bending moment, what is the first step? So the first step is done. Those who are interested in writing these steps, they can write कि पहला step क्या है, find out the support reaction. So it is done. Now take a section. So I have taken a section XX which is at X distance from support 1. Okay, so X distance. Now can we write the shear force equation for that particular section plane? Can we write? Okay, yes, why not? So I am writing here the shear force at section X. क्या definition बताई थी? How to find out? It is the algebraic sum of all the forces acting either side of the section plane. Section XX, left side में what are the forces? WL by 2. WL by 2. Positive? Yes, definitely it is the upward reaction force, positive on the left side. And the UDL, this much of UDL is available here. W into X. It is minus, yes, on the left side it is downward. So WL by 2 minus WX. What we are observing? This particular equation is the inclined line equation, y equal to mx plus c. So whenever we are drawing the shear force diagram, what we will do? We will draw the inclined line, y equal to, shear force is available here. Okay, this section, this equation is valid from where? It is starting from 0 to L. So I can put many values. So if I am putting x equal to 0, what it will be? Shear force will be WL by 2. If I am putting x equal to L, then shear force will be minus WL by 2. Yes or no? You can check कर सकते हैं, वैल्यू खुद रख के देख सकते हैं, ठीक. और those who are doing with me, वो अपना चैट बॉक्स में आंसर लिख सकते हैं. ओके, at x equal to L by 2, it will be 0. So this is the shear force. shear force diagram के लिए इक्वेशन भी पता चल गई मुझे. इक्वेशन के साथ साथ different values at different points at x equal to 0 and at x equal to L, at x equal to L by 2. So equation available, equation is like this, already explained here. At different positions, at x equal to 0, at x equal to L by 2, at x equal to L, it is available. Okay, कोई confusion नहीं, simple सी equation लिखी. Now I am coming to the bending moment part. Okay, now I am coming to the bending moment part. So bending moment equation यहीं से लिखता हूँ मैं. Okay, bending moment equation. Let me erase this particular. Okay, bending moment equation. Now I am writing the bending moment equation. Okay, so bending moment at section X. Bending moment at section X. क्या होगा? It is the algebraic sum of all the moments acting either side of the section plane. कितने forces हैं? There are two forces. One is the WL by 2, another one is the WX. There are two forces, so obviously two moment component will be there. So moment due to WL by 2 about section XX, it will be WL by 2 into X. And what will be the rotation tendency? It is clockwise and it is on the left side, so it will be positive. Now I am coming to the WX. This is the UDL. Where it will be effective? It will be effective at the midpoint. How far it will be from the section plane? It will be at x by 2 distance. So I am multiplying it with x by 2. So load into perpendicular distance. Will it be positive or negative? It is on the left side and anti-clockwise. So there it is minus, negative. This equation of bending moment is valid from 0 to L. So at x equal to 0, bending moment 0. At x equal to L, bending moment L 0. कैंसिल हो गया, चेक करें. ठीक है ना. Those who are available, those students, those who are interested seriously in shear force and bending moment, please मेरे साथ solve करते रहिए so that you will be comfortable. At x equal to L by 2, क्यों चेक कर रहा हूं मैं इसे? At x equal to L by 2, because at x equal to L by 2 मैंने निकाला था कि shear force 0 था, and the point where shear force is 0, where bending moment will be either maximum or minimum. So here I am putting x equal to L by 2, x equal to L by 2 put करके देख लें भाई. So it will be W L by 2 into L by 2 minus what? X equal to L by 2 रखना है ना. So W L by 2 into L by 2 into 1 by 2. So I hope it is coming out. यदि solve कर रहे हैं आप तो W L square by 8. And the nature of curve is, nature of bending moment curve is parabolic, x square. Clear, very clear. Question is clear. Okay. So the bending moment equation, here we can check. It is coming. यहाँ पर होना चाहिए, ये थोड़ा सा misprint है. It must be L by 2 at x equal to L by 2. Okay. So the bending moment already explained all these points. The bending moment equation is available to you. Then at different points the bending moment values. Okay. And now here it is coming the shear force and bending moment diagram. Simply supported beam subjected to UDL. Shear force equation कैसा था? Inclined line with negative slope. So it is or at 0 it was WL by 2, at L it was minus WL by 2, at L by 2 it is, at L by 2 shear force is 0. Inclined line equation ज्वाइन कर दिए तीनों पॉइंट इंक्लाइंड लाइन से. दैट्स इट. दिस इज द shear force diagram. बेंडिंग मोमेंट एट x इक्वल टू 0, 0 निकाला हमने. एट x इक्वल टू L इट इज 0. एट x इक्वल टू L by 2 वेयर बेंडिंग मोमेंट where shear force is 0, at that point the bending moment is maximum and it will be WL square by 8. So the very simple problem, एकदम simple problem है. I don't think there is any issue in with this. Very clear. Okay. Now I am reaching to the next one. Different type का load लेते हैं. Okay. The simply supported beam shown below carries a vertical load that increases uniformly from 0 at the one end to the maximum value of 6 kilonewton per meter of the length. At the other end, draw the shear force and bending moment diagram. It means अब UDL की बजाय I am considering UVL, uniformly varying load. Okay. So one problem related to it. So here comes the beam. What is the span? 12 meter is the span. 6 kilonewton per meter. This is the maximum intensity of the load. Okay. So first step is what? First step is to find out support reaction. For finding out support reaction, या तो मुझे याद हो कि UVL है यदि पूरी उस पर तो क्या होगा? Then it is, I think it comes out WL by 6 and it comes out WL by 3. If it is याद नहीं है, then what can we do? We can apply the equations R1 sigma Fy equal to 0, algebraic sum of all the forces, vertical forces. So R1 plus R2, these are the reaction forces at point 1, at point 2. It will be equal to what? The area of this UVL, area of this triangle. So it will be half into 12 into 6. Okay. Then I will be taking the moment. I will be taking moment about either about point 1 or about point 2. So whatever the point you want to select, you can take the moment. So because of R1 about point 1, the moment will be 0. Because of R2, the moment about point 1, it will be R2 into 12, R2 into 12. Then UBL बच गया, इससे भी ले लेते हैं भाई. So load is like this, half into 12 into 6. Where it will be effective? So I know the UBL will be effective at 2L by 3. Please निकालते रहें आंसर साथ साथ. Praveen Yadav is available. He is my student from second year. So please Praveen निकालें. How much? 2L by 3. Simple है. 2L by 3. So I can multiply it with 2 into 12 by 3. क्या आ गया आंसर? कैलकुलेट करेंगे, या तो मैं ऐसे कैलकुलेट कर देता. सो R1 R2 ये तो 36 आ गया. ठीक है. Then support reactions are coming out 12 and 24. So the first step is done. Very basic step. यदि ये गलत हो गया तो entire question will be wrong. Now what is the second step? Take the section plane. So now I am taking the section plane. Okay, section plane at x distance, support reactions already written here 12 and 24. Now I am writing the shear force and bending moment equation. So I am considering a section plane XX at x distance. So now write the shear force equation. Shear force at section XX, which is at x distance, and it is the algebraic sum of all the forces acting either side of the section plane. तो इसके लेफ्ट साइड में what are the forces? 12 पॉजिटिव लेंगे, मालूम है, now we are knowing. Then area of this triangle, area of this triangle, because this small triangle OAB which is on the left side, so that I will be considering. मैंने यहाँ ट्राइंगल ही बना दिया. ओके, इस ट्राइंगल का लोड लेना है. कैसे निकालेंगे? हाउ इट विल बी डन? माइनस हाफ इनटू दिस आई वांट एंड दिस आई वांट. सो ये तो मालूम है मुझे लेंथ, इट इज एक्स, एंड हाउ मच इट विल बी? इट इज डब्ल्यू एक्स बाय एल बाय द सिमिलर ट्राइंगल. कोई अलग से काम नहीं किया, इट इज ओनली विद द सिमिलर ट्राइंगल. विच टू सिमिलर ट्राइंगल? ओ ए बी एंड ओ सी डी. लीजिए, आपके लिए आसान कर देते हैं. ओके, clear? So like this we can write the equation. Okay, like this we can write the equation. So W क्या है? What is W? W, here is the W. 6 क्या है? From the bigger triangle. So W by 6 equal to x upon 12. So W equal to x by 2 it is coming. So the shear force equation, अभी आगे बढ़ाते हैं इसको, अभी complete नहीं हुई. Okay, now I am coming to this. What I will be writing here? I will be writing here 12 minus half into x, and what else? What else I can write here? मैं इससे कंपेयर कर दूं इसको x by l को, ठीक है ना? कंपेयर कर दें इसको w x y, yes or no? तो यहां कितना आ गया? w equal to x by 2. Now 0 plus x by 2 by 2. This is the x by 4 kilonewton meter. So it will be, therefore the total load over the length will be x square by 4. X square by 4. Getting or not? If it is not, then दोबारा से करते हैं. Okay, how much it is? यदि कोई प्रॉब्लम है देन हम इसको दोबारा से करते हैं. Definitely by x, this is y, this is x, this, it is 6, it is L. So y will be, what I will be writing here? I will be writing here by upon x equal to 6 upon L. So y equal to 6x upon L, I can write here. 6x upon L, and L is how much? L is equal to 12. L equals to 12. So that's why it is coming out x by 2. Now I have to take the area of the triangle. Area of the triangle. So half into x into y, and y equal to x by 2. Y equal to x by 2. So it is coming out x square by 4. I hope it is clear. Okay. Now the shear force equation. 12 minus x square upon 4. What is 12? That is the support reaction. 12 is the support reaction. X square by 4 इस छोटे से ट्राइंगल का लोड है, ट्राइंगल के एरिया से निकाला जो हमने. x square by 4. How it is? It is the parabolic equation. It is the parabolic equation. Okay. Now bending moment equation. May I check the bending moment equation at this particular point? Yes. Bending moment equation. Bending moment at point x. There are two load components, two force components which are contributing in shear force. So definitely two moment will be there, 12 into x, 12 into x. It is because of this support reaction, clockwise होगा, positive होगा. Then the second component is x square by 4. x square by 4 ये किसका load है? This is the load of this UBL. And where it will be effective? X square by 4. If you are knowing, then it will be at 2x by 3, and from section plane it will be at x by 3. So 12 into x minus x square by 4, which is the UBL, into x by 3. We are taking the moment about section, not about the supports. Okay, equation कैसी हो गई? We are observing cubic. So now we are available with the shear force equation. Now we are available with the bending moment equation. Okay, valid from 0 to L. So at x equal to 0. Now at x equal to 0, in this particular equation, the shear force is coming out 12. X को 0 रखा, it is 0. Shear force at x equal to 12, मतलब दूसरे support पर. So 12 minus 12 into 12 by 4, it will be coming out minus 24. And the point where shear force is 0, the point where shear force is 0, it is necessary because हमें maximum bending moment भी निकालना है. So that is 12 minus x square by 4, it is coming out 6.92. Calculate करिएगा, साथ साथ calculate करें, सिर्फ आंसर यहाँ से नोट ना करें. Similarly, for the bending moment, at x equal to 0, bending moment will be 0. At x equal to 12, bending moment will be 0. Simply supported beam के case में लिख लीजिए, at the support, generally the bending moments will be 0. And at x equal to 6.92, कौन सा point है ये? F equal to dm over dx. The point where shear force is 0. The point where shear force is 0. At that point, bending moment will be maximum. So it is coming out by putting this. Now you can see the shear force and bending moment diagram. Shear force diagram, it will be like this. Parabolic equation आई थी, parabolic equation. Bending moment, cubic equation आई थी. We can write the values also. Values कितनी आई भाई? At shear force 12 and 24. Shear force, it is 12, it is 24 kilonewton, 12 kilonewton. Here the bending moment is 0, bending moment is 0. Check कर लें, यही आया था ना? Yes, 0. And at 6.92 it is 55.42. It is 55.42 kilonewton meter. So this is the shear force and bending moment. तो दो तरीके की problems हमने ले ली. There are two problems, one related to UDL over entire length, another related to uniformly varying load over entire length with some numerical data. At least अब हम section डालना सीख गए. तो थोड़ा सा problem का standard, थोड़ा सा एक step ही आगे जाऊंगा. Nothing more than that. Which type of beam it is? It is simply supported. Subjected to two types of load. What are the two types of load? One is the UDL of 400 Newton per meter intensity. Another one is the point load at 6,000 at midpoint, which is the intensity of 6,000 Newton. So what is the first step? The first step is to find out support reaction. Very first step. Please, जल्दी से निकाल दें. I am waiting for 1 minute. 1 minute is sufficient enough to find out the support reaction. निकालिए भाई. Praveen, please find out the support reaction. निकालें. क्वेश्चन आपको करना है, क्वेश्चन मुझे नहीं करना एग्जाम में. एंड दिस इज द सिंपलेस्ट वन, बिकॉज आफ्टर दैट जो क्वेश्चन लूंगा वो 3 या 4 सेक्शंस के साथ लूंगा. तो डेफिनेटली हमें यहां कंफर्टेबल होना पड़ेगा पहले. ओके, रिटेन? नो. चलिए थोड़ी सी हेल्प कर देते हैं. R1 प्लस R2 इक्वल्स टू 400 into 8. This is the UDL plus 6,000. So it is coming out 9200 kilonewton. 3200, 6,000. R1 plus R2 equals to this. Now for finding out R1 and R2, write moment equation about point 1. लिख दिया. Because of R1, moment is 0. Because of R2, the moment will be R2 into 16. Then because of this 400 into 8, कहाँ पर होगा ये? Mid point पर होगा. So minus 400 into 8 into 8 by 2 minus 6000 into 8 equals to 0. Please check. Equation check करें. आपने भी यही लिखी है या कुछ और? R2 into 16 minus 400 into 8. 400 into 8 is the UDL and it will be effective at the midpoint already shown here, and 6000 into 8. And R1 and R2 क्या आ रहे हैं भाई? R1 and R2 are, anyone is finding out? No. लीजिए, चलिए, मैंने निकाल दिया R1 and R2. R1 is 5400 and R2 is 3800. Now for finding out shear force and bending moment at different points at different locations, and how will be the diagram. Okay, how it will be? अरे इरेजर क्यों नहीं आ रहा भाई? Okay, let's, क्या किया जाए अब? Now what to do for finding out shear force and bending moment? Now how many sections are required here? First question, how many sections are required? 2, because 2 variations we are observing in the beam. Loading condition एक बार change हो रही है, so that's why we are requiring 2 sections. One I am taking at x distance from 1. Okay, क्या होगी shear force equation? Shear force at section x. Shear force at section x. क्या क्यों नहीं रहा भाई? Shear force at section x. क्या होगी इक्वेशन? इसके लेफ्ट साइड के वट एवर द फोर्सेज आर देयर, द फोर्सेज आर R1. R1 कितना आया भाई? R1 is 5400. So 5400 positive, yes, minus 400 into x. This is the UDL. Is this the right equation? 5400 minus 400 into x. This equation is valid from which point to which point? It is valid from this to this. This equation SF at x at section x 5400 minus this. तो मैं दोनों को लेके लेंथ लिखे देता हूं. At x equal to 0, at x equal to 0, shear force कितना हो जाएगा? It will be 5400 Newton or kilonewton Newton. And at x equal to 8, how much it will be? We can calculate. Calculate करें, आंसर बताएं. It will be, how much it will be? 5400 minus 400 into 8. Yes or no? कितना आएगा आंसर? 5400 minus 400 into 8. I hope it is coming out 2200 Newton. Please check. And it is on the left side of the point C, which is the midpoint. So I will be writing here just left of C, because the section plane is on the left side. कहाँ पर ये check करना है? Where we have to check this? The point where we are getting the point load. So here at point C we are having point load. So on the left side of the section plane and on the right side of the section plane we will be getting different values of what? Different values of shear force and, okay. So on the left side at x equal to 8 it is 2200. Clear? Shear force equation is clear now. Now I am coming to the bending moment equation. Bending moment at section x. what it will be? It will be 5400 into x, 5400 into x minus 400 into x. Shear force equation में यही तो दो component हैं. And how far it will be from the section plane? X by 2. Equation check करते जाएं. Shear force equation, inclined line equation है, bending moment equation, parabolic equation है, ठीक है ना, 2 degree parabola है. So 5400 into x minus 400 into x by 2. This equation is also valid from where? From point 1 to C, from the midpoint. So at x equal to 0, it is 0, bending moment is 0. At x equal to 8, how much it will be? Calculate करें, x equal to 8 रखें इस equation में. Please put x equal to 8, how much it is coming out? रख सकते हैं, इसमें कोई बड़ी बात नहीं है. 5400 into 8 minus 400 into 8 into 8 by 2. Please calculate this. आपको ही calculate करना है. According to me, it is coming out 30,400 Newton meter. Check कर लीजिएगा. If you are not finding out, then you can check. Okay. So this is the bending moment. Now, the bund section is not sufficient because after point C, the condition is changing. So I am taking another section here. अब पिछले वाले x को भूल जाता हूं मैं. Now I am taking another x. अरे इरेज नहीं हो रहा है ये. ओके, मैं यहां निकाल देता हूं. ओके, एट दिस पॉइंट. यहां आ गया. गुड. नाउ इट इज ओके. पिछला मैंने इरेज कर दिया. नाउ आई एम राइटिंग द बेंडिंग मोमेंट इक्वेशन फॉर दिस पॉइंट. यहां section I am taking here, which is at x distance, which is at x distance. Okay. Shear force, this is the second section. First section is already done, so don't get confused. और यदि confusion हो रहा है तो then हम x1 x2 ले सकते हैं. सभी को x ही मानेंगे हम. Okay. So this is the section. What are the forces on the left side of the section plane? What are the forces? R1, which is equal to 5400. Then entire UDL is there. Yes, entire UDL is there. So that will be equal to 400 into 8. Then the point load is also here. 5400 minus 400 into 8 minus 600. How much it is coming out? What is the calculation? कितना आ रहा है? Minus 3800 Newton. And what we are observing? This is the y equal to constant equation, y equal to c. It means the shear force diagram will be a horizontal line. ये तो हम already बता चुके हैं कि where the zero load condition or only the point load is there, then the shear force diagram will be a horizontal line. So the equation is also suggesting the same thing. Now I am writing the bending moment. Bending moment at x. Bending moment, how much it will be? There are 3 force component, 3 load component, so 3 moment component. So 5400 into x, 5400 into x minus another load component is 400 into 8. And how far it is? 400 into 8, where it will be? 8 by 2, 8 by 2, जितनी लेंथ पर स्प्रेडेड है. मुझे कहां चाहिए मोमेंट? आई एम टेकिंग द मोमेंट एट दिस पॉइंट. सो व्हाट इज द डिस्टेंस बिटवीन दीज टू? फ्रॉम हियर टू हियर इट इज x, फ्रॉम हियर टू हियर इट इज 8 by 2. So I will be writing here what? x minus what? 8 by 2. It means I can write, यहाँ लिख दूं मैं, x minus 8 by 2. Another component which is 600. 600 कितना होगा ये? 600 into what? X minus this. I am interested in this distance. So this is x minus 8. Okay, clear? Itni baat clear? 5400 into x, 400 into 8, which will be effective on the midpoint of this 8 meters. So 400 into 8, this is load, and it will be effective. So x minus 8 by 2, this is the distance. 600. No, it is not 600. It is not 600. It is 6000. Okay, sorry. What it is? Okay, it is 6000. Sorry, मैंने यहाँ पर गलती से okay 600 वहाँ पर लिख दिया. It is 6000. Okay, this is 6000. और आप लोग कोई उसको चेक भी नहीं कर रहे. 3800. Okay, so this is 6000 into x minus 8. Now I am finding out what? I am finding out the bending moment. कहाँ से कहाँ तक? From point C to point 2. So I can put the values. For point C, the x equal to 8. So at x equal to 8, shear force vary करेगा क्या? Shear force तो x पर depend ही नहीं कर रहा. Shear force is not depending on x. So it will remain constant. It will remain minus 3800. कहाँ से कहाँ तक? From point C to 2. The bending moment is depending on the x. So bending moment x. If at x equal to 8, लिख दूं यहाँ पर, at x equal to 8, how much it will be? 5400 into 8 minus 400 into 8. This is what the UDL. 8 minus 8 by 2, so it is coming out 4, and this quantity will become 0. कितना calculate होके आएगा भाई? Please tell me at x equal to 8. I hope it is coming out 30,400 Newton meter. Already निकाल चुके हैं हम, पहले निकाल चुके हैं सेक्शन 1 से भी ये रिजल्ट. And at x equal to 16, let me erase this. It is not erasing. Strange. No way. चलिए हम इधर से ही काम कर लेते हैं. Now at x equal to 16. At x equal to 16. So what I will be doing? Bending moment कितना होगा? It is 5400 into 16 minus 400 into 8. x की जगह 16. 16 minus 4, 12. Here ये भी 6000 है भाई, ठीक है, माइनस 6000 इंटू 8, ठीक है ना, 6000. डोंट गेट कंफ्यूज, यहाँ पर वो गलती से 600 लिख गया था. इट इज 6000. हाउ मच इट इज कमिंग आउट? आई थिंक इट इज कमिंग आउट 0. सो नाउ द थिंग इज क्लियर. 2 सेक्शंस हमने डाल दिए यहाँ पर. ओके, नाउ how much, how it will be? Let me show the diagram. It is not getting erased, so why I don't know. ओके, सो लेट्स सी द डायग्राम. थोड़ा सा उसी पर बन के आएगा. हम ये इरेज क्यों नहीं हो रहा? नहीं इरेज तो सर ये आपने डिस्कार्ड वो कर दिया होगा कि पहले, आई थिंक इसलिए नहीं होगा. ओके, सो इज देयर एनी वे टू डिलीट इट? नो. ओके, कोई बात. सो नाउ इरेज नहीं हो पा रहा वो. ओके, सो नाउ वी विल सी the shear force diagram from this point to this point. Inclined line equation tha it was, okay. So inclined line at point C, which was the midpoint of that, at this point we are getting two values of shear force, one for the left side, another one for the right side. So for on the left side, for the left side it is 2200, on the right side it is coming out 3800, and from this point to this point it remains constant. So constant, okay. Bending moment at 1 it is 0, at 2 it is 0, at the center it is coming out 30,400 Newton meter. So like this we can draw the shear force and bending moment diagram. थोड़ा सा shear force diagram, bending moment diagram overlap कर रहे हैं, so that's why it is not coming properly, okay, but we can see here. I hope now we are able to write the equations, shear force and bending moment diagram equations, and we will be able to draw the shear force and bending moment diagram. If we are interested in more problem solving, then definitely in my next class I will be taking one bigger problem in which we will be putting 3 or 4 sections, and through which you will be getting a clear picture ki how shear force and bending moment by diagram will be drawn. But before that, please go through this particular video where you will be able to understand ki how to write the shear force equation and bending moment equation. So thank you very much for watching the video, and I hope you will be getting some knowledge, you will be getting some information. Thank you very much.